Okay guys, we're back. So we had just finished up example 1 showing how you can use the factor theorem to substitute in and find out whether something is a factor or not. Remember, you're kind of using the remainder theorem, but remember the remainder theorem just says that whatever you get as your answer is your remainder, right? The factor theorem takes it one step further. You still substitute the value in, but it says, well, if your remainder is a 0, then, or if your answer is a 0, that means your remainder would be a 0, and that takes it one step further and says that that binomial is a factor as a result. Because remember, we tested it out already. If you divide a number by a true factor, then you won't have a remainder, and then you can continue breaking it down more and more and more if you want. So in this case, no remainder meant 8 was a factor. And it gave me a nice number, 1072. I could continue breaking down. Unfortunately, and I already knew that 5 was not a factor because this number ends in a 6. I knew 5 was not going to work, so I picked that quick and easy one. Obviously, it didn't work, left me with a remainder 1, or we would say 1715 and 1/5. But either way, there's a remainder. 5 is not a factor. It left me with a remainder, and now because of that remainder, that 1/5, it's going to make it very challenging and difficult to break this down more and more and more. So again, we're looking for only the factors. So that's what this theorem does. It tells us we know when we have a factor because we'll have an answer that equals 0, which happens to be a remainder of 0, which means it's a factor. And then we know we're on the right track to use that to keep breaking it down. So now this says factor f of x is 3 equals 3x squared, or 3x to the third plus 14x squared, subtract 28x, subtract 24, given that f at -6 equals 0. Well, what that means is they're telling you in this case that if you plug in a -6, it's going to equal 0, and that is the remainder, or the factor theorem itself. It says if you plug in a number and you get out a 0, then that is a factor. Of course, not -6, but how it's written before they set it equal to 0 and solved it. So they already set whatever was here was set equal to 0, and they solved it and got a -6. So they actually got this. So if you want to go backwards, and then you would need to take this -6 and put it back over on the same side with the x. So to accomplish that, of course, you'd have to add 6 to both sides, and then you'd end up with this. So this is actually the factor. This is what they actually started with, okay? So this would be considered a root or a 0. But if it equals 0, then you know you can write a factor automatically. Just go backwards and write it as a factor. Okay, so because we know that this remainder is 0, we know that we can write the factor as x plus 6. We know it's a factor now. And we can use synthetic division. Now, why do we do that? Because we want to break it down. The original function here is a third-degree polynomial. When we break it down, we're going to take our answers here and we're going to write it as a quadratic. So let's track what they did. They took this third-degree polynomial. They said, I need to break it down. I need to break it down evenly with no remainder. So we'll talk about how you find this number -6 if it's not given to you. There is a way to do it, but they're going to give you the ones in the beginning. So like this one, they're telling you that one of the solutions is -6, which means x plus 6 is a factor. So they're getting you started. So of course you're going to use -6. You're going to break it down. Remember that when you use synthetic division, your answer is depressing the original polynomial. So instead of x to the third, this is going to be an x squared, then an x, then a constant, right? So that's what they did right here. They took this, they wrote it as a quadratic, x squared, right? And they brought it over. They used 3, -4, -4. See it? 3, -4, -4. Okay, not only that, but they are using their original factor too. See? They know that's a factor. That was a given. And then this is what we got when we did synthetic and broke it down. Well, now they say, wait a minute. If they want all the factors, because they're telling us to factor this, they want it broken down as much as possible. So here's what they're going to do. They're going to keep the original again, right there. See it? This is the one we were given. And they're going to take this quadratic and look at what they do. Man, they're smart. See this? These two parts right here come from factoring. They factored this quadratic function. Okay? So these are the factors. This is all three factors. All right? All right, so when you have a third degree polynomial, you will end up with 3 factors and 3 roots. Even if they're repeats, you'll end up with 3 different pieces. Okay, so these are the factors. Now remember, these are factors because they don't have equal signs. They've not been set equal to 0 and solved for. These are called the factors. If you wanted to solve all 3 of these as roots, the roots would be whatever you get when you do x plus 6 equals 0 and solve it, right? You're going to get a negative 6 as your root. Then it would be whatever you get when you do 3x plus 2 equals 0. You'd have to solve this all the way down. And I can do some mental math, and that'll be negative 2/3. And then the final root would be taking the factor, set it equal to 0, and solve it. Those. These are called roots. These are the 3 places. This thing is going to zigzag back and forth like an S shape, up and down, and it's going to cross or touch the x-axis in these 3 places, those roots. Okay, so that's the way we're going to use the factor theorem. It's going to help us break it down, down, down to the factors. And then often it'll also ask you for the roots also. Okay, so let's do another one then. All right, the final one on this section, before we try one, says one of the zeros of this function is x equals 7. They're already telling you one of the zeros. They've already set it equal to 0 and solved it, and they got a 7. So they're telling you it's a root or a 0. What that means is you can use it in synthetic division and you won't have a remainder. Also, you would want to, if they used a 7 as a root, you'd want to take it back to its factor form, right, where there's no equal sign, and take it back to the factor x minus 7. That's important because you got to list it as a factor down here. Okay? So they're giving you a hint. They're saying, hey, use 7. Use synthetic division, use 7, and you'll be able to depress it really nicely. And that's what they do. So let's walk through this. They took this big one. They wrote down their coefficients. They brought down the first number. They're doing synthetic division over and over again. They end up with a remainder 0. So it's going to make a nice, pretty, depress it down to a quadratic. So this is going to be my x squared. This is my x. That's my constant. So look at how they write it. They took the 2, 5, and 3. 2, 5, 3. They gave it the 2 an x squared, the 5 is an x, and their constant has no x, like that. And then, of course, they said, I need to factor this. So they factored it even more. This quadratic got broken down some more. And this is something that you're going to have to do. So when I get back, we will definitely work on the factoring the quadratic again. We've done it a lot, but just in case. All right. Now, as you know, if I wanted to write these as roots, they don't ask for the roots. They ask for, it says completely factor the function. They didn't ask for the roots, so you stop here. However, if they did ask for the roots, you set all factors equal to 0 and solve. So For roots, set all factors equal to 0 and solve. That's all factors that have an x. Okay? So you'd set x minus 7 equals 0, solve it for x. 2x plus 3 equals 0, solve it for x. X plus 1 equals 0, solve it for x. Okay. So this one says use synthetic division to find all the factors for the equation f of x equals x to the third plus 3x squared minus 4x minus 12, given that f at negative 3 is 0. This is under the you try section, and unfortunately you're going to have to write this down. But I do want you to write the whole question down, just because you're not going to, if you just have some math on there, you're not going to know what we started with. So pause the video, write it down. And this is at the very bottom of your booklet on the right-hand page that said factor theorem. Okay, so it says use synthetic division to find all the factors. So it wants all the factors. Since it's a third degree, there will be how many factors? That's right, 3. So you'll have 3 sets of parentheses just like before. They're telling you that f at negative 3 equals 0. What does it mean when the number you evaluate for equals 0? That's right, it means this is a root or a solution. Okay, so that means I'm going to be able to use it out here in my synthetic division. What it also means is I need to go backwards. That meant that they set something equal to 0. It was x plus something or x minus something. They set it equal to 0, and they got a negative 3. That means you're going to have to go backwards, rewrite this as a factor again. So I think we can all tell that our factor is going to be x plus 3. Okay? But we are going to use x minus 3 for our synthetic division, and I'm going to list all of the coefficients here. Bring down to get started. Okay? And I'm going to have, let's see, negative 3. Add straight down, that's a 0. Negative 3 times 0, 0. Add straight down, negative 4. Negative 3 times negative 4 is a positive 12. Add straight down, and there's the last one is my remainder, 0. Worked out just like they said it would be 0. Okay, so now my depressed polynomial, I go down from third degree, down a level. This will be x squared, that'll be x, and this will be a constant. So how would that look? That would look like this. 1x squared, or just x squared, plus 0x, meaning we don't even have to show this at all, and then a minus 4. And of course, we need to use our original factor down here too, because they want to show them all three pieces. Okay? Now this is factoring a quadratic. It's also called the difference of squares, if you remember that. You might want to look at it just as, how am I going to multiply to get x squared? Of course, that'll be x and x. What am I going to multiply to get a 4 here and here? Multiply to give me a 4, but add to give me a 0 in the middle, because there's no middle term at all. Well, I know my sign is negative, so these signs will be opposite to give me that negative. I do know also that it's either 2 times 2 or 4 times 1. Both of these multiply to give me 4, but when I combine like terms or whatnot, I need them to also kind of cancel out and give me a 0, and that'll be these guys. So one of these is a positive 2 and one's a negative 2, so that when you do your distributive property over and over and over again here, the middle term will drop out, and you'll get a negative 4 as your C value, your final term here. This is also the difference of squares. If you saw that, then you know this format right away. Okay, and these are the factors, all 3 factors. And that's what they ask for, and so that's where you could stop. But recall that if I wanted roots, they didn't ask for roots, but the next section will. So I just want to review again. Oops. You're going to set the first one, this one, equal to 0. The next one equals